So in this example, we're going to look at polymorphism. That is where one object really exists as part of many different classes. So here we have the idea of a shape as our base abstract class. Now, you can point to things. So I have things on my desk. So this is a shape, right? But not really. This is a circle, and a circle can take certain aspects from a shape. It can take its name, it can take its area, things like that. But if I'm pointing at something specific, something that's actually tangible, that means I'm not pointing at the abstract base class. I'm pointing at a derived class from it. So shape is on our hierarchy way up here. It is the furthest away from tangible. Now, underneath that, we would have a square or a rectangle. Now, the way this is set up, we actually have rectangle would come next. And you can tell that rectangle is our next most child entity here because on line number 2 we have extends shape. So that means that in the hierarchy, first comes shape, then comes rectangle. Because rectangle extends shape, it's going to inherit everything that was available inside of shape. So you'll notice that right here I have a length and a width. You'll notice that I have a set name, a get width, and a get length. So from shape, we're inheriting its name and its get name. So either one of these, your rectangle, has a length and a width, and it has a name. So what we're doing here in our rectangle class is we are overriding, we are superseding those things that were included in our abstract class with new functions, with new data members. So we're going to keep going from there, and we're going to have our square Java. And you'll notice here on line number 2, again, public class square extends rectangle. So we're going to inherit everything that was available inside of rectangle, and we are going to become more specific than that and define what makes a square. So what does this look like when we run our main.java? So as we mentioned back in the chapter, when we are instantiating an object of a certain class, what actually happens first is all of the superclasses, starting with the most super, so the abstract base class, are instantiated first. So even here on line number 4, there it is, when I am instantiating an object of square class, you'll notice over here in my output window, the first thing to arrive is this is a shape, because that is the most abstract base class. Then comes this is a rectangle. That's because square extends rectangle, which extends shape. So those two are called first. And then finally, this is a square. You'll notice that that comes from inside of our constructor for square. So let's get back here to main.java. There we go. I am using here square.getName, square1, rather, my mistake, square1, sq1.getLength, sq1.getWidth, and sq1.getClass. Now, you'll notice in square.java, I do not have a getName, getWidth, getLength, or set for any of those. Those are being inherited from elsewhere. Where are those coming from? You'll notice in rectangle, I have a set name, I have a get name, I have a get width, and a get length. And here back again in main, there are my gets, and that's what we need. So again, it is an advantage to the developer to have this kind of is a relationship happening here. So a square is a rectangle, and a rectangle is a shape. So because those are true, I can use way down, so abstract base class shape, then comes class rectangle, then comes class square, and that square has access to the data members and the functions of rectangle. And because rectangle is extending shape, we have the access to the data members and functions from shape. I meant rectangle before, and then again in shape. So that is the idea of inheritance, where one generation to the other generation to the other generation, and we have access to the internal functions and data members. So that makes your job as a developer easier.